Hello everyone, today I'm gonna show you some demo of LoopQuest. LoopQuest is a data-centric embodied AI training and evaluation platform. So basically, this platform hosts simulation environments and organizes the world's data with action labels for embodied AI foundation model training. So let's jump in right into the environments. So LoopQuest hosts multiple different kind of simulation environments for all kinds of reinforcement learning like tasks. So it includes like very basic environments all the way to some Mojoko based simulation environments, and there's other simulators also are supported, especially for my research. I write my own simulator called SynGlucose to simulate the blood glucose of a diabetes patient. So basically, all these environments are supported to like upload the data into the platform, and then we can visualize the data easily. So let's see the functionalities. So first of all, let's click into some environment. This is the most well-known environment for reinforcement learning, CORDPO. So in this page, we can see all the observations and action are listed here, but actually it's not named nicely here. So the platform can support like renaming these observations and add some variable description for each of the observation. So this functionality is much easier for people to understand each of the dimension of the observation. What do they mean? And plus, the AI, especially large language model, can use these as their prompt to based on conditioning on these prompts to generate the right action for it. So that's kind of my ideal world, like large language model. One single large language model can generate all kinds of actions based on the environment's metadata, like these observation description here as a prompt. So it could generate the action correspondingly. So that's just my ideal world. I think the AI is still not there yet, but this is what this platform is aimed for. The second functionality is this LeaderBoard or dashboard that will list all the experiments run on this platform, and it will sort it by the return or reward. So this will support like the reproducibility and how to compare different algorithms in a fair way. So that's another benchmarking functionality I want to support here. So LoopQuest, this environment, basically support two functionalities. One is the run evaluation. The other is create dataset. Let's go to each of them to understand. So here we support the evaluation, like people running evaluation locally in their own computer, but save the data to the cloud so that you can visualize the data easily to understand how that evaluation was going. And we also support the evaluation on the cloud, like remote evaluation, that you can input some Hugging Face repo ID and then the corresponding file that saves the model. So for now, we only support the stable baseline 3 model. Then you can start running the evaluation. The server on the cloud will evaluate the agent for you and then show the results. And the third option is just some for demo purpose, like just run a random agent. I just want to test out how LoopQuest is working here. You can do that. So okay, let me first sign in, then I can show you how to utilize this running evaluation function here. So for example, I want to run the bipedal walker. I just add this environment. It just show up here. And then if I want to run like 5 episodes, each episode have like 100 steps. And the project name, let's name it as demo. And you can input some description for demo purpose. And some experiment name. I right now just have some very dummy experiment name. Let's skip the experiment description. So if I want to run it locally, if I hit run, basically this will tell you how to run this locally, and then you can copy paste this code into your local code editor, and then do some editing for your custom policy, and then you can run it locally. So that's how you do that. I can show you how to do that. Evaluate the agent on the cloud. Let's say I wanna evaluate 5. That's too many. Let's say 2 episodes and 100 steps. Let's just run the random agent on the cloud, and this is for demo test. Let's just run it. Okay, so the evaluation is running now, and we can see how the evaluation goes in our home page. Okay, it already notified us the evaluation has been successfully run. You can go to this link to see the results. Okay, let's go to this link. Another way to go there is just click on this project. You can go to the same places. Okay, basically this is the running is successfully done, and you can see each of the step rendering is recorded on the cloud, and we can jump into different episode. And the most important function here, LoopQuest support, is the providing the human feedback. So you can see that whichever time step that you don't think the agent is doing the right thing, then you can thumbs down and leave some feedback saying the robot is failing, is falling down. And the LoopQuest will record all these human feedbacks and presenting it in a nice way finally when you create a data set. And you can also visualize all the observations in time series, and also the action in time series and the corresponding report. You could see all of them. And yeah, that's just a single run. And actually the platform supporting like you run multiple experiments and compare different experiments. Let's do that. Again, I'm gonna run 2 episodes. Each episode run 100 steps. Same project name. Let's name it test 2 to differentiate the test. Let's run another one. I'll close it. Let's see whether, okay, it's saying it's done. Yeah, that's the test 2. If you select the test, you can actually compare the different experiments side by side, and then you can also provide the feedback. And all the time series are also like comparing each other. you can understand what's going on, like between these two different experiments. That's the reward you can see here as well. So that's just the functionality of the website. There's some more comparison features, like compare the different reward and compare the experiment setup. Right now the experiment setup is just like empty, but you can definitely input the configs. Very similar to weights and bias. You can input all the configs here so that you understand what are the differences between different experiments. Yeah, and this is the environment. Again, you can edit all the observation variables and action variables. So yeah, that's kind of the evaluation functionalities. Oh, by the way, we support different kind of like space in OpenAI Gym. So we support all the different kind of spaces here. We support the fundamental spaces like box and discrete, everything, and also including the composite space like dictionary. And each of the dictionary, you might have nested dictionary that's also supported. We'll parse the data recursively as a tree, so that you don't need to worry about like, oh, some of the complicated space is not supported. They are all supported. I can even show you one example with the dictionary here. I think this one is a dictionary, the Gymnasium robotics. Yep, this is a dictionary space, and you can see that each of the names already here. But the underneath the box, there's no name for each variable, but you can specify each of the variable yourself. And desired goal and observations. So yeah, that's the evaluation part. Later on, like we want to create a data set for our offline reinforcement learning. I'm going to show you the whole workflow I did for the offline reinforcement learning. So for example, let's see, still bipedal walker, since we have run some data already here. Like you can see that these two data, let's for example, like we just run and then hit the create dataset button. So this is basically how you create a dataset. The dataset is a Hugging Face dataset interface. So okay, let's see how to use that. I already have this Jupyter notebook opened, and same thing like from the LoopQuest, we could import this low data sets. And by specifying the experiment IDs here, like these two experiment ID is some experiment I created for my type 1 diabetes simulation task. I can show you the experiment I run. I think it's here. This one. So basically it ran like 30 different individuals with type 1 diabetes, and then like it generate this kind of data sets. You can see it's just like the blood glucose and the carbohydrate that the patient taken and the insulin injected into the body, and the action is the insulin amount. So, and this is the experiment ID, which is the same here. So here I just specify two different experiment IDs, and I want to load the data set. Let me run the code. So okay, it's already loaded, and this data set have like two features. One is the metadata, one is the steps. So for each of the for each iteration of the data set is an episode of data. You can see like the metadata has some meta information for this environment, and because this is just like one virtual patient, and it shows its age, body weight, and some diabetes factor ratio thing, and the whole steps of the episode is here. So yeah, this is too long. Let me delete that. Yeah, so if you get the steps, you will get the a list of the steps. And if we take a look at each of the steps, it contains the action. The action here is just a list of two floats, and the environment ID and the number of episode, experiment ID. If we have the annotation like thumbs up and thumbs down, there we could see the human feedback listed here. There's an image ID that's for the rendering. We don't load the image by default, but if you want to load the image for your training, it's doable. The observation, reward, and some other miscellaneous fields. So that's just one iteration of the dataset, and basically we have 240 episodes here that we can use for training. Next step is like we want to process this dataset so that the format is trainable using, like, let's say GPT model. The first thing we want to do is to tokenize it. So I wrote my own tokenizer for my type 1 diabetes research. So basically, like, we can write some map function to tokenize it, and we want to convert. We want to convert the reward and the observation and action into some token we need. And here we just call like the dataset and map this tokenization function, and you will get some tokenized dataset. So here, let me show you the tokenized dataset. It's becoming it turns the steps into a sequence of tokens. That's basically it. The meta sequence is for the metadata. This is more like some we want to train some GPT that's conditioned by this metadata as well. So that's the tokenized dataset. And later on, because usually some transformer-based model has some context length limit, we want to truncate the sequence into the context length limit, so it's directly trainable by a GPT model. This is basically just map this truncation operation so that you get chunks of sequence for GPT training. That's what I did. Like the number of examples just changed from 240 to 100,000 ish different chunks. Then we can do the train test split, leveraging the Hugging Face dataset API, and save the data to some folder we want. So that's basically it. We already processed the data and save it somewhere in our disk. Later on, like if you want to train it using PyTorch, you can convert the data into Torch tensor format, and then you could even use some Torch data loader to load it, and then produce a batch of it easily, very easily. So yeah, that's basically how you get the data set and process it and then prepare it for a GPT model training. I even have a training data ready. Let's just make it a spin. I think the data name dataset we save is offline IL data, and then we could just change the data folder and then we can train it using my own GPU to train it. So this training has the GPT model I'm training is I only have like 24 megabytes of parameters, and then it's already sufficient for this amount of data. And now the program is like working on like training the model. So I'm actually already trained the model somewhere. It's saved in some checkpoint. And then once we have this model trained, we could very easy to evaluate the performance of this model. Again, using LoopQuest. Let's see. Online evaluation. I have this online evaluation code written. Like first part of the code is just like let me stop the training. It's very slow actually. First part of the code is just like loading the trained model into PyTorch, and then just create those environments I have, and then define a GPT policy. This is a GPT style model, so like we basically want to keep some context window of data or like sequence token, and input it into the model and let it generate the next several tokens for us. But what we need is the action token, and it's basically the first two token will be the action code token. We just get it and then return it. Finally we just call the LoopQuest evaluate local policy. Once we run it, the evaluation of the model will be uploaded to the cloud. Run this online eval. There's something. It's in the development mode. Let me turn it on. I'll turn it off. Okay, yeah, once we trying to upload the data into the cloud, sometimes it will ask you for the token. Like the token will expire after some time. So sometimes it will ask you for the token again. Yeah, so like the evaluation is happening right now using the model trained, the GPT model trained. And then the data is uploading to the cloud, like slowly uploading to the cloud. We could even see that without waiting for it's finished. So this is just the evaluation data. It just run, like it's currently running right now, and you will see the change. Yeah, like it's changing now. Yeah. All right. So I think that concludes all the demo I want to show you. So for summary, in summary, just this platform is for you to collect the data for your offline reinforcement learning, and then train it and then evaluation back into the platform, so that this kind of it's a continuous iteration process. Like you generate some data, you train a model, and then you evaluate it, and all the data are uploaded back to the cloud, and then you can use that data for training again. So yeah, that's I think that's this workflow concludes um, close the loop of the entire development process, and I hope the data can be accumulated, and you could easily visualize it, annotate it, and then will speed up your embodied AI training process nicely. All right, thank you.